there, geometry students. This is Ms. Hefty here. We are going to do a review of some algebra today that we're going to need in section 3-6. What we're going to have is we're going to be given two equations and we're going to be asked to find a solution. And so I'm giving you an example here of x plus y equals 2 and x minus y equals 4. And there are a number of ways to find solutions. The first way you can find a solution is by graphing, and we're not going to solve by graphing, but I wanted to talk briefly about it. When you solve by graphing, you need to get it in the y equals mx plus b format. And so when I take my first equation, I need to get my y alone. So I'm going to move my x. So that's going to be y equals a negative x plus 2. And you already have the graph on your notes sheet. They've already graphed that, or I have. I'm right here at 2 on my y-axis. That's what the b is. And then I have a slope of 1, so I go down 1 and then over 1. So down 1 and then over 1, and then we've drawn the line. The second equation, I need to get y alone. So I had x minus y equals 4. I need to have a positive y, so I'm going to move my y to the other side. X equals y plus 4. Then I need to get y alone, so I'm going to move my 4 to the other side. X minus 4 equals y. And if you need to go ahead and rearrange that, y equals x minus 4. And that was already graphed for you as well. Negative 4 is where it crosses the y-axis. It has a slope of 1, so up 1 over 1. So then the solution would be where the two lines intersect, and we already have that identified as 3, negative 1. Now, the other ways to solve equations, to find where the solution is, where they're crossing, is to do either substitution or elimination. So let's take a look at this same equation and apply substitution and elimination to them. All right, so I need to do a substitution. In order to do a substitution, get one of the variables alone. So in my first equation, I'm going to go ahead and get y alone. So that's going to get me 2 minus x. Now I'm going to substitute all of that in for y. Now some people are saying, Mrs. Hefty, I'd like to get x alone. It's going to come up with the same answer. So if you got x alone, that would be correct as well. I'm going to take my second equation, x minus, now I'm subtracting all of y, so that needs to have parentheses around it, equals 4. Go ahead and distribute your subtract sign. So I'm getting x minus 2 plus x minus a negative is a plus x equals 4. X and x is 2x, combining my like terms, minus 2 equals 4. Move your 2 to the other side. 2x is 6. And then divide by 2. X equals 3. Now remember on the previous one that the x was 3. The ordered pair was 3, 1. Remember, 3, 1 was the answer in the graph. I could go back to that and look. So do you see here, guys, that the part of the ordered pair, the x part is 3. Now I need to find the y. So I'm going to use this equation right here to find my y. Y equals 2 minus 3. Oh, this is negative. I'm looking back, that was negative. So now my y equals negative 1. So do you see here? The y part of the ordered pair of the intersection spot was negative 1. We could also solve it using elimination. When you're using elimination, you need to line up the variables and the numbers. See how things are lining up here? My x's are lining up, my y's are lining up, and my numbers are lining up. And then I always tell my students, read down. You want to eliminate, you want to get rid of. When I read down here, those y's are gone. If they weren't gone, I could add a subtract sign in there, so I need to get them to match, and then I need to make it be 0. All right, how many x's are there? Well, this is an x, and this is another x. I have 2 x's. And my 2 and my 4, they don't have any signs there, so they're positives. It's a positive 2 and a positive 4 makes a positive 6. I get x equals 3, and again, do you guys see? That's what I got graphing, and that's what I got by substitution. Then plug it into one of the equations. So I'm going to take my 3 plus, I'm using the top equation. You could use the bottom if you so like to. Get y alone. Y equals minus your 3, you get -1. You guys see here again, same answer. So when you're solving, looking for solutions to equations, you're looking for where they cross each other, where those 2 lines cross each other. You're finding an ordered pair, a point. All right, let's take a look at our other 2 examples. Find the solution. So in example number 1, I need to decide, am I going to use substitution or elimination? I do not have one of the variables alone, so I'm going to eliminate substitution, and I am going to do elimination because my variables are lining up. So I am going to do elimination. Now when I read it down, none of them are gone, so I need to get them to look alike. I am going to choose my y's because then they're going to be, if I can get those 2 to be 6's, I'll have 6y minus 6y, and that'll be 0. So I'm going to go ahead and multiply my top equation by 3, and I'm going to multiply my bottom equation by 2. And the reason why I'm doing that is because I want to get them both to be 6y. All right, so when I write my top equation over, 3 times 7 is 21x. 2y times 3 is 6y, and that equals 6. Bottom equation, 2 times 2x is 4x. 2 times a -3y is a -6y. And remember, my goal was to get those to be eliminated. And they are going to be, and then a -28 times 2 is a -56. Now I'm going to read down. 21x and 4x gives me 25x. My y's are 0. If they aren't 0, I have to add a subtract sign to everything. And then my 6 minus 56 is going to get me -50. Divide, x ends up equaling -2. Now I need to find the y. So I'm going to plug it into one of the equations. I'm going to do it to the first equation. I've got 7 times -2 plus 2y equals 2. That's 14, -14 plus 2y equals 2. Move my 14, so I'm going to add 14 to the other side. That's 2y equals, add 14, that's 16, divide by 2, y is 8. So my ordered pair, my final answer is an ordered pair. X is -2 and the y is 8. So it's an ordered pair. It's where the 2 lines are crossing. Example number 2. I have x by itself, so I'm thinking this is going to be a substitution. It's set up to substitute. So I'm going to take 2y plus 6, and I'm going to substitute it right in for x. So I've got half, and then I'm substituting, instead of x, I'm writing 2y plus 6. Minus 6 equals 3. go ahead and distribute your half. Half of 2, half times 2 is 1y, plus half of 6 is 3, minus y equals 3. Now I'm going to get my like terms together that are on the same side here. And when I have 1y minus y, my y's are disappearing. I get 3 equals 3. I don't have any variables left. I'm sneeze. Okay, I'm back. Sorry about that. At this point, I don't have any variables. They've fallen out. 3 equals 3. That's a true statement. This is true. So I actually have the same line. This is the same line. Both of those lines, if I graph them, they're going to be on top of each other, the same line. And so I'm going to have infinitely many solutions. Let me show you here, guys. I'm going to go back up here. Let me get my eraser. This equation, the second equation, if I times everything by 2, then I'm going to get 2 times a half is x, and I'm going to get minus 2y equals 6. Do you see, people, that those two are identical equations? If you need to do this, go ahead and move your 2y to the other side. That minus 2y becomes positive 2y plus 6. See, this equation is the same as that equation right there. If I graph them, they are going to be on top of each other. That is going to be infinitely many numbers are going to work in those two equations. Had these two numbers been different, had I gotten 5 equals 7, can 5 equal 7? No, that is false. That's false. And that's no solution. Those lines are going to run parallel, actually. All right. You guys have a great afternoon, and I'll see you in class tomorrow.